have seen at some of the prior meetings. Dr. Rangan is going to go through an update that provides for you some very useful information about some of the findings that we've been able to assemble based on all of the data and the experience that residents have been having with regard to some of the symptoms. And I think this will give you at least an update as to where we're at as of today with regard to all of the data, both air quality data as well as symptoms that residents have experienced. And then we'll both be around to help with any questions or concerns you have on any topics at all. So with that, Dr. Rangan.
Thank you, everybody. Do our best here. I've got a remote mouse here, and we'll see if we can advance with these slides okay. Now, this is just to give you a little bit of background on myself. My name is Dr. Cyrus Rangan. I'm a medical toxicologist with the Los Angeles County Department of Public Health, and I work for the Environmental Health Division. And so our task is, we run a program that's called the Bureau of Toxicology and Environmental Assessment. And our job there essentially is to kind of view the county as a population in terms of population exposures to chemicals in and around our environment. So obviously when the Porter Ranch gas leak situation occurred, that was sort of right up our alley in terms of what we need to do to respond to this. So this presentation is just an overview of sort of what we have done up until now, the kinds of things that we've analyzed and interpreted, and we want to give you our impressions about what we feel is going on in terms of the air quality and in terms of the general state of health of the community. In addition to all that, I'm also a practicing pediatrician at Children's Hospital Los Angeles. I'm also one of the assistant medical directors at California Poison Control, so all of this is sort of in my wheelhouse, so to speak. So I'll be happy to answer any questions that relate to any of those issues as we move through today's presentations. This presentation right here was given at the Board of Supervisors meeting on Tuesday by our health officer, Jeffrey Gunzenhauser. And so I'm just going to essentially give you the same presentation that was given there. I'll give you sort of a briefer form, because I know we have some others to hear from today. Our colleagues from the fire department, the management district are also here today as well. But we'll be able to get through this presentation and give you the highlights of what we have been observing in the community with regards to air quality and health. So our activities have really centered around the following. We've been consolidating, analyzing, and reporting on results of air monitoring that have been performed by a number of different agencies in Los Angeles, including Southern California Gas and their consultants. The lion's share of the data has been coming from that source. South Coast Air Quality Management District, California Air Resources Board, and Los Angeles County Unified School District as well. And we've been assessing not only just the air quality, but also the health impacts on residents in the surrounding communities around the gas leak, and also some assessment of impacts on pets and animals in the community as well. When it comes to the chemicals of concern, the kinds of things that we've been analyzing most closely as far as the air quality is concerned, we've been focusing primarily on these three classes of chemicals. The first of which is methane, which you're all very familiar with. That's the main fuel component of natural gas. The second is sulfur odorants, and sulfur odorants, and I'm sure many of you have already been well educated on this issue up to now, but just in case there are some people who have some questions about what this is, sulfur odorants are the chemicals that we add into the methane in order to create a natural gas mixture, and those chemicals are designed to be able to be smelled at extraordinarily low doses so that you can detect a gas leak that might be in your house, because methane has no odor. But once the sulfur odorants are there, then you can smell it. And that, unfortunately, has created an awful perfect storm as far as the gas leak is concerned and the symptoms that people have had in the community. We'll talk about that in just a moment. In addition, we've been looking at a number of other chemicals, including benzene and chemicals related to benzene. I'll get into those details in just a moment. But the reason that we started focusing on those chemicals was that back in the end of October and early November, when the gas company was first trying to characterize the actual leak itself and trying to figure out exactly how to fix it, at first they had the impression that this something could have been fixed maybe within a few days or so, maybe even a week. But then they determined that it was a much more complex problem that required a much more complex solution, one that would require 2, 3, 4 months in order to fix. So once we heard about that around sort of mid-November, that's when we determined that we can't just look at these chemicals that are in the gas mixture, like methane and sulfur odorants. We need to be taking a much closer look at all of the other chemicals that we know that can come along for the ride when you are looking at natural gas extraction. And that includes benzene and related chemicals. And the reason that we talk about benzene, that we like to focus on benzene so much, is that of all the chemicals that we're going to be talking about today, benzene is the one chemical out of those that is the known human carcinogen. It's the one that we have absolute evidence can cause human cancer if you're exposed to enough of it. We're exposed to benzene all the time, all day, 24 hours a day in Los Angeles. But if you're exposed to enough of it at high enough levels over certain periods of time, then yes, you can have an elevated risk of cancer. So that's why we wanted to make sure that we had a handle on that, that we were looking very closely at a chemical like that, so that we could understand where it was going up, was it going down, was it staying the same, so that we could make sure to have a good handle on the characterization of that chemical and understand the potential long-term health implications. Now, when it comes to the, this is a little bit hard to read here, but I don't know if there's focus this a little bit. I think it's just a little bit out of focus here, but take a look at that. It's a little bit better. So I'm not going to spend a lot of time on this map here, but basically what I want to do is just point out a few key features here. Wherever you see a green dot, that's where we've been taking lots of air samples that are what are called grab samples or instantaneous samples. And what is an instantaneous sample? It means a 10-minute collection of air. And we have hundreds and now into the several thousands of those kinds of samples that have been generated and sent to the laboratory and analyzed. Where you see yellow dots, those are areas where we've taken different kind of sample. It's what's called an integrated sample. And what that means, it's a sample that's not just 10 minutes of air, but it's actually 12 hours of air. And then that's sent to the laboratory to make a determination about what's in it. So we're analyzing for all the same chemicals in all of these yellow and green dots, but we're doing it over different kinds of durations of time. Now, why is that important? Well, these grab samples in these green areas are ones where we can take those quick samples to determine what is the air looking like right now, and then take that to the laboratory and analyze it. But what the yellow dots represent, these 12-hour samples, it gives us a much better representation of what is a person potentially breathing over the course of the day, right? So that's why we wanted to make sure that there were both of those kinds of samples, so we can get an idea about what people are breathing in right now at any given time versus also what they need to be breathing in over the course of a day-long exposure in the Porter Ranch area. This is another representation of some monitors that are going on as well. Both the South Coast Air Quality Management District and also the California Air Resources Board have these monitors that have been set up in the community as well, spread out in sort of strategic locations. And here's what they're doing for just monitoring just for methane. So we're monitoring for a bunch of other chemicals in those previous dots that I showed you on the previous map, and then methane with these monitors down here. So we have a pretty huge sort of cache of monitoring stations all over the community to make sure that we are covering our bases with the neighborhoods. Now, this is a little bit daunting when you look at this whole table here, but I want to point out the highlights of this, what this all means. As I mentioned before, we're looking at a few important chemicals. The first of which there you see is methane. Under that you see benzene. And under that you see two very, very long names. Those are those sulfur odorant chemicals. One of them is called terpbutyl mercaptan. The other one is just called tetrahydrothiophene. And so those are the two sulfur odorants that are added to the gas mixture up here at the Aliso Canyon site in order to give it that characteristic smell. Now on the right here, these thousands right here, these are the total samples that were taken. This is between October 30th and January 11th. These numbers are now up to about 1,400 or 1,500 right now as of today. But this is just the data that we have through January 11th. And of those 1,080 samples, 1,080 of them actually were positive for methane. What was the range of the methane? It was right here in this range, 1.3 to 4,340 parts per million. But when you look at the averages, it's right here in that range, 59.7 parts per million. What does that mean? Well, you look over here and you see what the health protective level is for methane, 50,000 parts per million. So that's the level of methane that will essentially cause an explosion. So we're well below that. We're in fact light years below that in terms of methane. So we don't have any risk of a methane explosion that's going to be occurring in the Porter Ranch community. Now this particular table is actually referencing within the facility. So we have monitoring stations up at the facility. We also have them down at the community. So this table is just referencing what's going on up at the facility. And we'll get to the community ones in just a moment. Now when you look at benzene, I'll just walk you through this one as well. Up until January 11th, 1,079 samples were taken and sent to the lab for benzene. 363 turned out to be positive for it. Going down to the range here, you see the average at 1.3 at the level of the facility. But this is the range that you really worry about in terms of acute exposure at the facility itself in terms of benzene. So here we're not worried about benzene becoming a problem for the people at the facility. If you look over here, then at the sulfur chemicals, again, several thousands of samples have taken for both of these as well, and none. Does that mean that there's no mercaptans in the air? No, it doesn't. What it does mean, though, is the following. When we take our instruments and take them to the community or at the facility, and we take an air sample, take that back to the laboratory has a certain ability with the machines that they use to detect mercaptans down to a certain level. The problem is the amount of mercaptans that are in these samples are actually below the detection limit abilities of the laboratory instruments. But why is that important? Our noses are a lot better than laboratory equipment at detecting mercaptans. So the smells that you've been smelling, the sulfur-like smells that you've been smelling in the community, have been there, even though we're getting 0 readings on the actual instrument detection. But they're there because our noses are designed to be hundreds, if not thousands of times more sensitive than the instruments that we use to try to detect this stuff. So what we are saying is that what is present in the air is an extraordinarily low level of these sulfur chemicals, but certainly enough to cause the odors to occur. And why is that important? We'll get to that in some subsequent slides here. Now, the rest of these slides in this section here are basically the same kind of table. And the one I just showed you before were those instantaneous graph samples, those 10-minute samples occurring at the level of the facility. And here is the facility again, but the 12-hour samples, where we take 12 hours of air from that laboratory. And essentially, we're seeing numbers that are more or less in the same kind of range. You look at the methane, we're seeing this average here, 64.1, well below our health protective levels. The benzene, 0.98, well below our health protective levels. And the mercaptans, same things, where the sulfur compounds, we're noticing the same kind of phenomenon that we're not observing them as far as the laboratory is concerned, but yes, we're still observing them in terms of our nose. When you look at the community, now we're down the hill from the facility, and we're looking at the boundary. In other words, the junction between the bottom of that hill and the community. So here we're looking at our 12-hour samples that give us an idea about what people are breathing in over the course of the day. This is the one that applies to you all here as residents in the community. And we have methane samples here. Again, we're still detecting methane, but at an average of 5.3 parts per million. It was just mentioned that over the past couple of days or so, there's been a little bit of a fluctuation upwards of methane that has been detected in a couple of the monitoring stations that are out there. But again, we're talking about elevations in that range of about 40, 50, 55 parts per million. So not nearly close to the 50,000 parts per million necessary to cause an explosion. And then again, with benzene, when you look at the benzene readings of our 12-hour monitoring, we're looking at very low levels as well, 0.18 as far as the average is concerned. And the average that would be, the average level you would need to be exposed to really be concerned about a long-term chronic sort of health effect from benzene is in this range right here, 1.0 parts per billion. So that 0.18 is significantly lower than that, so that's encouraging news as well. Same situation going on for the sulfur chemicals in the community, not detectable by our laboratory instruments, but still detectable by our noses. And here are the, just to kind of wrap up this section here, the community graph samples. So not the 12-hour samples, but the ones that we're just grabbing 10 minutes of air. Similar kinds of findings, where we're seeing that the methane average is 8, we're seeing that the benzene average is still in a lower range of about 0.38, and still these non-detects of the sulfur chemicals. To put it into some granular context for you, when you look at these benzene readings, again, you can concentrate on that because that's the number of carcinogen. We want to know where that's going. When you look at these numbers, 0.18, 0.38, yes, the benzene is present, but how different is it compared to, for example, the air that you may breathe anywhere in the Los Angeles County area? And when you look at the averages that you see all around Los Angeles County, benzene tends to run in the average of, depending on where you are, what time of year, anywhere from about 0.1 all the way to maybe 0.7. So the average levels that we've been seeing in the Porter Ranch area with all of our monitoring has been pretty similar to the averages that you would see if there was no Porter Ranch gas leak, or if you were somewhere else in Los Angeles County we're breathing in more or less the same kind of air, despite the fact that the gas leak is there. So that's encouraging news as well. This slide, again, is just more of a representation of what I just mentioned. So it's more of a graphic form of the tables that I had sort of just shown you before. But this is just the average weekly concentrations of methane in the community. The thin black lines here are the full range that has been detected on these dates, and the green is where the averages stay. So the averages still are in these very, very low ranges, and certainly not even approaching the explosion range for something like methane. So we don't have that level of concern about methane exposure. When it comes to the benzene concentrations, similar kinds of findings. Now, obviously, there's been a lot of fluctuation in this as well. When you look at all the averages, including all the kinds of sampling that we've gotten from the various different agencies, we're still looking at average benzene levels that, despite this fluctuation, are still remaining below this number right here, this magic number of 1. That's 1 part per billion. So that's the range that if you were exposed to 1 part per billion for an extended period of years, yes, you could potentially be at risk for an elevated risk of cancer. But if we're below those ranges, and again, in the same kind of range that you expect to see in most of the rest of Los Angeles County, then we can feel pretty confident that you're not breathing in air that's putting you at that elevated risk. Just to give you a little bit more of an overview about what we're doing. So we're not just looking at air. We're looking at air because we want to interpret those air results in the context of what they may do to you. And when it comes to these kinds of chemicals, like for example the methane, which of course is an explosion risk, it doesn't really represent a risk as far as inhaling it is concerned. Methane's really not much of a toxic chemical. Go ahead.
I noticed you didn't address radon, which is one of the chemicals that's in there too.
Yeah, we'll get to that at the end. Yeah. So with regard to something like methane, as I mentioned, it's not something that we regard very much as a toxic chemical when you inhale it. You can pretty much inhale all the methane you want, and nothing really happens to you. So that's at least encouraging. When it comes to something like the sulfur compounds, now the sulfur compounds are sort of the wild card here, because although we're not detecting it with the laboratory equipment, what we are noticing is that people certainly are smelling it, and people are getting some real symptoms. And we'll go over those symptoms in just a moment. But the symptoms that people get essentially are what we call the physiologic reaction to the odors. So it's not that you smell something and you kind of feel funny. It's you're smelling something and you're actually getting some real symptoms. Now, that doesn't happen with everybody. I'm sorry. So that's something that doesn't necessarily happen with everybody. Some people can be in this community and say, I don't smell anything. And in the same house, you can have another person who says, I do smell something, but it's really not bothering me. And yet a third person in the house says, yeah, I smell something and I feel like I want to throw up, right? And that's happened, I'm sure, in a lot of your houses. And those are the kinds of complaints that have been coming into the Department of Public Health as well. And so basically what is happening is that there's a lot of individual variation when it comes to people's responses, their physiologic response to odors. And you can characterize it in a number of different ways. Let's say, for example, you grew up with someone in your house who was a smoker. And you can go ahead and be outside and you can smell people smoking a cigarette, and it doesn't bother you too much. Maybe you find it, I don't want to be around that person, but it doesn't bother you too much just to kind of be around people who are smoking. And then there may be another person who lives in your house who can't even be within 50 feet of the person who's smoking because of those odors. So there's a lot of individual variation in terms of how people react to odors, and that's what we've observed in this situation here in Porter Ranch. And so those mercaptan odors, those sulfur odors, are responsible for the vast majority of the symptoms that we've been seeing in this particular situation. When it comes to something like the benzene, we're not noticing that people are getting everyday symptoms like people are with the sulfur compounds. There, we're monitoring benzene because, again, of that potential risk for lifelong cancer. That's the reason to monitor something like benzene. So that just gives you an overview about why we're monitoring those particular chemicals. Now, in terms of the actual effects on human health, we're looking at a number of different avenues to sort of assess what's going on in terms of human health in the community. The first of which is that we've sort of established a Department of Public Health complaint line. We've got several hundred complaints that have come to our offices where we've assessed what's been going on with the community in relationship to these odors. Our Community Resource Center has been established, as you're all aware. We've also done a lot of outreach with medical providers. So medical providers who've either called my office or we've had discussions about general issues surrounding the gas leak, and also several discussions about individual patients as well. And then we've also issued notices and guidelines to medical providers about how to deal with patients who have been exposed to the gas leak. And we've also looked at some issues affecting animal health through our veterinary clinic outreach with our veterinary services offices in public health, outreach to large animal vets, outreach to animal shelters as well, and also reports from pet owners as well. So when you look at this is a representation of where the health complaints have been coming from. As you can imagine, it follows a very sort of a standard pattern of where all the residences are in the community surrounding the gas leak. That green dot in the middle is where the actual facility is, and this is where the symptoms have sort of been fanning out. Most of our complaints have been coming from the range of 1.1 to 2 and also 2.1 to 3 miles away from the facility. That's where the lion's share of all our complaints have been coming from. But there have been complaints coming from farther distances as well. You can see 3.1 to 4 miles, 66 complaints, 4 to 5 miles, 74 complaints, 5 to 10 miles, 81 complaints, and a few complaints even outside of that 10-mile zone. Now, once you start getting farther and farther away from the facility, it gets harder and harder for us in a public health department to assess whether your symptoms are really due to the gas leak or whether it might be something else. But we've been erring on the side of caution with this, so that if you are having those symptoms and you are actually smelling those odors, and it is kind of coming together at the same time, and when you leave your home you start to feel better, well, that gives us a fairly decent projection about what's going on. So we've been kind of including all of those in the same net, so to speak, to make sure that we are characterizing how far these odors and these complaints have been going out. This is what we call a complaint density, and so this is just sort of a complicated map that we use in the public health realm whenever we have situations like this, and they don't happen very often to this severity, but basically this shows about where the concentration of complaints are occurring. Once again, the green dot at the top there is the gas facility, and where you see the reddish and pinkish areas over here, that's where you see a high complaint density. In other words, more people per square foot are complaining in these areas than in the areas that are farther away in these sort of blue zones where you see fewer people complaining per square yard or whatever you would like to say. So close to the facility, right next to the facility, obviously there's a concentration there, and a little bit sort of southwest of the facility, so to speak, another density over there. And why you see those discrepancies is difficult to say, because it could be wind patterns, it could be any number of issues, and especially when you're talking about an issue that varies very much from person to person in terms of your variable response. Difficult to characterize exactly why a pattern like this exists, but it does show that people closer to the facility in general have been generating complaints than people farther away. Here's the range of symptoms that people have reported to us, and I'm sure that lots of people in this audience have experienced these very symptoms. Now, not to say that everyone has experienced all of these symptoms, but when you look at just the volume of complaints that we've gotten, where it says N equals 600, so that means 600 different complainants calling us at the public health department, 61% with headaches, 40% with some form of nausea or vomiting or stomach ache or stomach discomfort, maybe some diarrhea as well, 32% with bloody nose complaints, 27% with respiratory and breathing symptoms. You just kind of go down the list and see all the different kinds of symptoms that people are getting. And by and large, these are associated with people smelling the odors and then having these complaints, and then having them essentially on a daily basis as the odors continue. So there are some people who have called us and said, I smelled something yesterday, I don't smell anything anymore, and I feel fine. Then you have others who say, I smelled something yesterday, I smelled it, or the day before, I smelled it yesterday, I smelled it today, and I'm starting to get sick. And every day that goes by, I get sicker and sicker and sicker. And when that started to happen in November, when we saw that this problem wasn't diminishing, it wasn't going down, it was actually kind of amplifying and moving up, that's when we went ahead and issued our directive from the Public Health Department to the gas company to offer free temporary relocation assistance to anybody who wanted it. So we didn't establish criteria. It wasn't because of a headache or because of dizziness specifically or anything like that. If people found their symptoms to be unbearable, they were allowed to move out and get temporary relocation. And really that was just to provide an avenue for relief for anyone who just said, I just can't live in my house anymore because of these symptoms. Or the smell is so bad it's just making me sick in general. So that's what that directive was for. And so we didn't make it a mandatory evacuation because, as you well know, half the community is still living up there. And a lot of people aren't smelling anything. And some people are smelling things and not having symptoms. So there was no necessity for a mandatory evacuation. So that's why we made it a voluntary relocation. So people who were experiencing those symptoms would have an option to be able to move out and get some relief from what was going on. So once again, this is just a repeat slide from before. So I've already kind of gone over this about the litany kinds of things that we've been doing. But just to give you just a brief summary about where we are, and then I'll move on to some of these other issues as well, such as radon and reoccupancy issues. The Public Health Department, what we are doing is that we are continuing to closely monitor and interpret air quality and health data collected from within the Aliso Canyon Storage Facility and the adjoining community of Porter Ranch. What we want to make sure that you understand is that once the well has been sealed, once the actual repair process has been completed, we're not going to stop monitoring. We're actually going to continue monitoring for a long time after that. And we're not going to cut back on the current monitoring that's going on. The current monitoring that's going on will stay in place, and will stay in place for as long as we think that it needs to stay in place. So we'll be working with our colleagues at the Air Quality Management District to continue to get those numbers, continue to interpret them together, and determine what needs to be done thereafter. Once this leak is fixed, we view that as step one at the Public Health Department. We don't view it as a final step. We view it as step one. Once that flow of gas is stopped, great. That's the perfect step one that we've been waiting for quite some time. But we know that there has been uncertainty surrounding the emissions of gases from this facility all throughout this entire process. Once that leak is stopped, we want to make sure that we watch these environmental conditions and the air quality until things return essentially to a normal or baseline level in the community. So right now we're still seeing those little elevations of methane. We're still monitoring benzene. We're still smelling the mercaptans up in the community as well. So we want to continue to monitor that whole process until we are sure that things have returned essentially to baseline. So while methane levels have remained above normal methane levels are somewhere in the order of about 1 to 2 parts per million in general. So we're still seeing averages that are above that. So while they remain above normal, they have remained below that flammability limit and at all the locations, and have decreased substantially over time. They're not back to normal, and we'll continue to monitor until that gets there. The sulfur odors, well, those have remained certainly below the instrument detection limits that I mentioned to you before during this entire period, including immediately after the leak. Even at the locations near the leaking well, still wasn't detected up there, but yes, our noses are detecting them. So those odors continue to be present, and odors are causing symptoms in some members of the community. So we want to make sure that not only do these conditions return to normal, but we want to make sure that the odors go away as well. That's important to us, because that's the reason that the directive was issued in the first place. And then with regard to benzene and other chemicals, we're still going to be monitoring for that. All the community sampling sites that were originally detectable at levels above the average outdoor levels for the region, but peak levels continue to remain below the acute exposure thresholds. So we're still looking at benzene levels that we don't consider at this point in time to be a threat to your long-term health. But we'll continue to monitor that issue again, even after the leak is plugged, and even after the state has confirmed that the leak is plugged. We're still going to continue to do several rounds of monitoring after that to make sure that things are returning to normal and stay there. Now, one question came up about radon. I'll just kind of mention that here as well. The reason we haven't talked about radon much here in this presentation is because it hasn't become an issue. So we have been monitoring for radon. The reason that we wanted to monitor for radon, just so everyone is clear on this, is that we had concerns about worker safety when it came to radon. Why is radon a problem? Well, radon is a gas that gets produced below the Earth's surface. And radon can come up from the surface depending on the pathways that radon has from a geological standpoint to make it to the surface. Now, if you're at a gas facility like this and you're going to be excavating 8,000 feet deep in order to repair the problem that's going on in the well, that raised some concern with us that if the workers up there are going to be in that environment, we want to make sure that they're monitoring for something like radon just to make sure that it's remaining at levels that we can accept. And so what we found is that the average radon level up at the facility has been 1.7, and the units are picocuries per liter. What's the significance of that number? Well, in general, we start to get worried about radon when radon levels reach a level of 4 picocuries per liter. And that's for an indoor space where radon may accumulate over time in radon-rich areas. So we're looking at 4 in an indoor space, that's our level of concern, but at the facility we're seeing 1.7, and we're seeing it in an outdoor space. So we really have no level of concern that radon is becoming a problem for the workers up there. And the state radon folks have conferred on that, and they agree with that assessment. So we don't have a concern about radon becoming an issue. We did want to look at it because radon, just like benzene, known human carcinogen, so that's why we wanted to make sure that it was being looked at. over the course of this entire ordeal for everybody. But we haven't seen levels of radon that have reached critical levels that we would be concerned about.